Alright, so left hand side, right hand side, 2x plus 3 on the left hand side, 1 on the right hand side. X is negative 1. So anywhere we see x here, we replace by minus 1. So I'm going to come here, I'm going to replace x here by minus 1. So it's going to be 2 times minus 1 plus 3. So 2 times negative 1 plus 3. This is just 1, so I'm going to carry that all the way down because it's not going to change. So 2 times minus 1 is minus 2 plus 3. So minus 2 plus 3 is 1. Now I have to compare my final answer here to my final answer here. I can see they're the same. So that tells me that my solution is correct. If these two are different, that tells me my solution is wrong. And I need to check something. I need to check for what I did wrong. So, solution is correct. Let's move on to another kind now. How about ax plus b equals c? Something of this nature. An example is 2x plus 1 equals negative 1. So the first thing we need to do here is distribute the 2 to the x and plus 1. So we're going to multiply this and we're going to multiply this. So 2 times x is 2x. 2 times plus 1 is plus 2 equals minus 1. So now we must get rid of 2 and get rid of 2. But remember, you must first get rid of the number not attached to the x, and then secondly get rid of the number attached to the x. So plus 2, I'm thinking of what I can do to get rid of plus 2. Well, if I do minus 2, it's going to be 0. So I can do that. So minus 2 on the left side. Automatically, I must minus 2 on the right side. Plus 2 minus 2 is 0. I have 2x left. Minus 1 minus 2. I add these 2. I get minus 3. So now, 2x, what can I do to get rid of this 2? Well, I can divide by the same 2. Then it will get rid of the 2. So, divide by 2. I must do the same thing on the right side. The 2's are cancelled out. And x is negative 3 over 2. Or if you like, in decimal, negative 1.5. Let's do the last kind that we have. How about if we have x over a plus b equals c? X over a plus b equals c. A does not equal 0. So, example is x over 2 plus 1 equals 3. X over 2 plus 1 equals 3. So, we have to get rid of this first. is not attached to the x. And secondly, we'll get rid of this divided by 2. So plus 1, the opposite is minus 1. So I'm going to minus 1 from each side. So now, this is gone. 3 minus 1 is 2. So on the left side, I'm only left with x over 2. So x over 2 is 2. So x over 2 equals 2. So now I'm just going to cross multiply here simply. I'm going to say over 1. It's all the same. I'm going to cross these two together and cross these two together. X times 1 is x equals 2 times 2 is 4. 4. And that's it. Alright, so the next example. So complete this table of values. Y equals x plus 1. So what is a table of values? In a table of values, we have the input side and the output side. So in this case, we've got x and all the values here, and then we have y, and we're supposed to have some values here as well. So we call this one here the input, and then this one the output. We're calling this one the input because we've been given all the numbers to input, and then when we make our evaluations or calculations using these numbers, they're going to produce an output. So the outputs are now going to be here. Now, for this session, we're talking about linear relations. So those equations for these ones are called linear relations because the relationship between the x and the y, the relationship is linear. That is, if the input is going up like this, then the output is also going to go up. So there is consistency, basically. So complete this table of values for y equals x plus 1. So let me just say for y equals x plus 1. I can see a y here and an x here. So I'm going to take all the values for x, plug them in, and then solve for y. So for example here, I'm going to have y equals, so x plus 1, x is 1, so 1 plus 1. So this is 2. So 2 is going to be here. So basically, you always take the equation you have, you plug in whatever you're given, in this case x, and then you solve for the other one, y. So when x is 2, you plug it in. Y is 2 plus 1, that is 3. When x is 3, you plug it in. 3 plus 1 is 4. In many cases, because it's linear, there is a relationship like I was saying earlier on. So after doing a couple of them, you might be able to even figure out the other numbers without actually calculating them. So here we can see that the x's are going up by 1 each time. 1, 2, 3, 4, 5. And the y's appear to be going up by 1, to 2, to 3, to 4. So from there, this one will probably be 5, and this will be 6. And that's going to be correct. So this is a linear relation because this is going up steadily by 1, and this is going up steadily by 1. So similar things are going on. So it is consistent. Because of that, it is linear. Another example. The equation of a linear relation is y equals 9x minus 7. Some ordered pairs in the relation are all this. Now I want to mention from here, each of the lines here are ordered pairs. 1, 2 is 1, 2, 3 is another ordered pair. 3, 4 is another ordered pair. 4, 5 is another ordered pair. And so on and so forth. So, this was all ordered pairs. The difference now is that we did not make a table, which is fine. So we didn't make a table. Instead, we just combined all the ordered pairs together. So, find the missing numbers in the ordered pairs. So this one is complete, complete, complete. This is missing, this is missing, this is missing. So let's try and do, just looking at time here, let's start with doing these two, and then if there is still time, we can do the last one. But once we've done these two, you'll understand exactly what we're supposed to be doing anyways. So I'm going to start with this one. So 2 and something. We have no idea what this is. So now we know that in your ordered pairs, the first number is always representing x, your input, and the second number is always representing y, your output. So we have to come to our linear relation, plug in whatever we're being given, whether it's x or y, and then solve for the second one. So solving for the other one. So we're being given x equals 2, we want to solve for y. So anywhere we see x here, we put 2. So x is here, we're going to put 2. So I'm going to say for the first one, x is 2. So y equals 9x, so 9, 2, or 9 times 2, minus 7. So 9 times 2 is 18, minus 7 is 11. So our ordered pair here is actually 2 and 11. So the input is 2, the output is 11. So I'm going to write it here. So that's our ordered pair. So the missing number here is 11. I'm just going to put a check mark on top of the missing number. Let's move on to this one. We're being given our output, y is 38. We have no idea what x is, our input. So we're going to go here. Wherever we see y, we put 38, and then we solve for x. So y equals 9x minus 7. That means 38 for y. So 38 equals 9x minus 7. Equals 9x minus 7 because this is y. So we have to solve for x. So again, so we're going to try and get rid of everything around x, and then so that will be our final answer. So, and remember, you have to get rid of this one first. It is not attached to x, and then you're going to get rid of 9. So minus 7, the opposite is plus 7. So I'm going to try that first, and it's going to work for sure here. So I'm going to plus 7 on each side. So this is gone. I have just 9x left here. On the right side, I have 45. I have to get rid of 9, so I can divide by the actual 9. And then I have to do that on both sides. So the 9 is cancelled. So here, the greatest common factor is 9 because 9 divides into 9 and it divides into 45. So I can say, how many times does 9 go into 9? Is 1 time. How many times does 9 go into 45? It is 6 times. So this is 6 over 1. So x equals 6. So therefore, x equals 6. Over here, y equals 11. Here, x equals 6. So this is going to be, our order pair is going to be 6 and 38. So our input is 6, is x. Our output is y, it's 38. Now let's just go for the last one, 4. They're asking us for this one right here. So I know x, because it's always x and y. We know x, we don't know y. So we're going to write this and plug in x equals 4. So that'll be y equals 9x or 9, 4 minus 7. 9 times 4 is 36 minus 7 is 29. So therefore y is 29. So y is 29. So our ordered pair is 4 and 29. All right, we're moving on to another example here. So this is on the graphing linear relations. So graphing linear relations. So earlier on we were saying that for linear relations, so when we say it's linear, we're saying that as this is increasing, this other one is increasing. So there's consistency. Or as this one is decreasing, this other one is decreasing. So if I can show us an example in our table of values here, we can see that this one is increasing by 1 every single time, and this one is increasing by 2 every single time. So that means they're consistent, and because the increment every single time is the same. So that means that we're dealing with a linear relation here. So usually whenever you graph a linear relation, you're going to have a straight line. The straight line can either be going up or it can be going down if it is decreasing. So here we're going to learn, so we've already talked about table of values and input and output and the x variable and the y variable. So now we're going to use a real life problem here, or a word problem here. And we're going to learn how to graph table of values. An equation for the linear relation is C equals 11 plus 2n. So, where n is the number of toppings on pizza, that is n, and C is the total cost of pizza in dollars. Here is the table of values. So number of toppings, so the more the toppings you have on your pizza, the more expensive your pizza is from our table of values. So construct a graph for this data. Describe the relationship between the variables n and c here. Find the ordered pair on the graph that shows the cost of a pizza with 6 toppings. So, construct a graph. So we want to have a graph here. So we're going to have something like this. So one thing that's always very important when constructing a graph is labeling. So please always label your graph. You have to label here, and give it a title. So here, for my title, I'm just going to say toppings versus cost of pizza. So toppings versus cost of pizza. Now on the bottom here, I'm going to say toppings So toppings is N. So please always tell us the symbol for each one. So topping is going to be N. So we have N here. So we're going to go with that. So here we're going to go with cost. Cost is in dollars. So I'm going to do cost here. It's in dollars. Now I can go from here. I can look at the smallest and the biggest and make sure I'm including those here. And for the cost, 11 to 27, I want to make sure I'm including those here. So I'm going to start from N. So for N, 0 to 8, I want to have that here. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to do this to show that it's continuing there, and just to show it's continuing. And 11 to 27, so I have to start in such a way that I'm going to have enough to get up to 27 here. So I'm going to decide to go up by 5. So before you draw, please try out whatever you're looking to do here to make sure that you have enough space here to get the maximum that you need. So I need 27. So I'm going to go up by 5. So 5, 10, 15, 20, 25, 30. So I have enough. 5, 10, 15, 20, 25, 30. So now, the way we do our plotting on the graph is most people would like to use dots, so I'm just going to do that here. So we're going to go from the horizontal, 0, and then without taking off our pen, we're going to go up to the vertical for 11. So 0 for horizontal, we move up vertically to get to 11. We put a dot there, 1 and 13. I go 1 to the right, and then without lifting up my pen, I go up to 13, right there. I do 2 and 15. I go straight to the right to 2, then go up to 15 right there. The next one is 3 and 17. So I'm going to go right to 3 and up to 17. 4 and 19 is the next one. 5 and 21 is the next one. 6 and 23 is the next. 7 and 25 is the next. 8 and 27 is the next. Whenever you're doing yours, please make sure you use a ruler. I'm just going to use hand here. I'm just going to connect all the dots. So they're saying construct a graph. All right. So this is our graph here. So yeah. So I've got our title, our toppings, our cost. I labeled, and then you just go like that. So you always take, so let's say it's 2 and 15. So N is on the bottom. So that means you go right to that 2. And then 15 is vertical. You go up to 15. So you do the first one. You don't lift your pen. And then you do the other one. One is always left, right. The other one is always up, down. Another thing I want to mention here is there will be certain graphs that you will need to actually take a ruler and connect all the dots. And there will be certain graphs that you don't need to connect the dots. That you just leave all the dots alone, and that's it. And I think that's the example that we have here. So we can just leave all the dots. So as you do more of these examples and you gain more experience, so you have more understanding of that, of when to just have dots and of when to have a straight line across. So describe the relationship between the variables in the graph. Now we can do this from the graph. We can also do this from the table. It's easier for me to do from the table because I can say as the number of toppings is increasing by 1, my cost is increasing by $2. So as the number of toppings is increasing by 1, my cost is increasing by $2. The same thing here. As the number of toppings is increasing by 1, my cost is increasing by $2. So I can see the fact that this is going up means there's an increase. So I'm just going to do that here. I'm going to write B very quickly here. So as number of toppings, the number of toppings, the cost of the pizza is increasing by $2 as the number of toppings is increasing by 1 each time. And the last one is C. Find the other pair on the graph that shows the cost of a pizza with 6 toppings. I'm going to do this from the graph as well as from the table of values. They're asking for 6 toppings. I can see 6 toppings right here. So that means that when you're having 6 toppings, you're going to pay $23. Now let's check over here too. Now 6 is this one. Exactly. So this means that when you're having 6 toppings, I'm going to go up there. I'm catching this dot. I'm going to take it all the way and trace it to the left. I'm going to get 23 right here. 23. So when you have 6 toppings, you have $23 to pay. And this takes us to the end here. Thank you.